Section 53 is on finding volume with other cross sections. So as we just talked about, not everything is a solid of revolution, as we call it. So they're not all going to be circular cross sections. Sometimes we have other things. So on this first one, it does kind of look like a circle, but it's actually only a semicircle for the cross section. So you guys can see in your picture, do you guys see how we have like a chop here? And that chop is a semicircle. Okay. So let's sketch out. So suppose we didn't have that picture and we just had to sketch out what was happening here. So it says it's bounded by the lines of x plus 4y equals 4. So let's solve that for y. So if I have x plus 4y equals 4, I'm going to have negative x plus 4. And then I'm going to divide everything through by 4. So I'm going to have negative 1/4 x plus 1. So as I start sketching that out, I'm going to have a y-intercept of 1. And I'm going to have a slope of negative 1 over 4. So down 1, over to the right, 1, 2, 3, 4. Oh, man. All right, so we have this line. And then it's also bounded by x equals 0 and y equals 0. So it ends up being this triangular region right here. So I realize in the picture that you have above, we have an x, y, and z axis. So our x-axis is here, our y-axis is here, and our z-axis is here. So if you imagine taking this picture and putting it as like the floor, do you guys see it? Here's our line that we had back there. I didn't draw that very well. So there's where it started at 1 and it goes all the way to 4. Do you guys see the x, y, and z axis? It's kind of confusing. I know you guys don't do a lot in 3 dimensions. It's really fun doing calculus in 3 dimensions. That's Calc 3. All right, so we want to take these cross sections and we want them to be perpendicular to the x-axis. Do you guys remember when I showed you with your hand and I said chop, 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 and I made that little sound, right? So I'm making my chops like this. Okay, so is my hand going from x value to x value or y value to y value? X to x, so I should integrate with respect to x. And each of these chops is going to have a semicircle coming off of it. So you're going to have all these little semicircles. You guys see what I'm drawing? It's kind of hard to see. So I'm going to have all these like little semicircles there. Okay? So, question. If I have one of these semicircles, this distance up and down, what's that called for the semicircle? It's the radius, diameter, circumference, area. Diameter. It's the diameter, yes. How do you think we find that distance in terms of x? It's this to this, right? How did we do things when we wanted a distance from here to here? What did we do? We took the top curve minus the bottom curve, right? So what is our top curve? It's that negative 1/4 x plus 1, and our bottom curve is y equals 0, and we have a semicircle coming up off of it. Do you guys see that? And then we have those infinite. Maybe it's best if I didn't shade it in originally. So it looks like that. Yeah, it's kind of like half of a cone, but it's like a slant cone. I don't know how to describe this.
90 degrees.
Yeah, kind of weird. All right, so our diameter, so if I'm kind of keeping some notes here, my diameter was that blue line that I drew in, which is going to be the top curve minus the bottom, which is negative 1/4 x plus 1. So how would I get the radius in order to figure out the area of the semicircle? I need the radius, right?
Divide that function by 2.
I take it and I divide by 2. So I could write it as negative 1/8 x plus 1/2. So then my area of a semicircle is not pi r squared, but it's actually pi r squared divided by 2, right? So it's going to be pi, this negative 1/8 x plus 1/2 squared, and then all divided by 2. Okay. So we talked before about how our volume is really just our area integrated, and our x values went from 0 to 4. So we're going to have like that. So our area of the semicircle, which I could call this a of x, right? That would be perfectly acceptable if I wrote that as my setup on the test, as long as I've defined what a of x is and I have it all set up like that. But if I wanted to put this in, I would say 0 to 4, I'd have my pi, my negative 1/8 x plus 1/2 squared over 2 dx. And you could clean it up a little bit by pulling out the pi and pulling out the 2. Oh, did I mess something up? No, I got over the 2. Okay. So I'm going to pull out my pi over 2, and then I have that negative 1/8 x plus 1/2 squared going from 0 to 4. And there's lots of ways you can write this. So in the first period class, what I did is I left the radius as like this, the negative 1/4 x plus 1 over 2. So when I squared it, I had that whole thing over 4, and then I pulled it out. So I ended up having like a pi over 8 out front. So if you have some different setup than your friends, you probably are going to get the same answer. It just might look a little bit different on that setup. That's why I feel like it's the easiest just to write it like the generic 0 to 4, a of x dx, as long as you've defined the radius on that. Okay, so when we do this, so we do our math 9, so we get 0 to 4. I'm going to have my negative 1/8 x plus 1/2, and I'm going to square it, and then I'm going to multiply by that pi over 2. So I believe we should get pi over 6 as the answer. Okay, so that was a semicircle, which really isn't dramatically different than the solid of revolution, except this revolution line, this is kind of what Cole was talking about. You guys see it'd be kind of like slanted. It's like that whole cone is kind of slanted. So how do we do that?
Either because it's not a perfect like
yeah, it's not
you
quite.
can't just draw a midline.
Yeah, it's not a perfect. It's kind of weird. Yeah, so it's not really technically a solid of revolution. Okay, so find the volume of the solid whose base is the region inside the circle. X squared plus y squared equals 9. Now the first period class, they were struggling this morning. I know it's rough, a Monday morning. And they were like, what's x squared plus y squared equals 9 look like? You guys know this, right? Okay. I know. I was like, guys, remember this formula from geometry that we've done a lot? So you've done this in geometry, algebra 2, and pre-calc.
What?
Conic sections, right?
What are those?
So we have our center is 0, 0, and our radius is 3. Because, as I said, this is the formula x minus h squared plus y minus k squared equals r squared, the circle formula. So if you didn't know that, write that down, because we should know that. Now, if you kind of forgot the ellipse or hyperbola equations, I'd maybe cut you a little bit of slack, but circles we should know.
What's the conic equation?
All right, so that's our circle.
You ever make cones with them?
So now we're going to do this thing, this cross-section taken perpendicular to the y-axis. So think about my little annoying sound effect. What are we doing with our hands? Yep, Josh did it. Up. We started at the bottom and we went to the top, right? So what y values am I between? Negative 3 to 3. And I'm doing these chops this way, right? They're not all on the, kind of made it look like it was all on the whole numbers. They could be anywhere. And we're going to have these squares coming up off of it. So it's really hard to draw this in 3 dimensions. So imagine one of those chops has a square coming off of it, right? Do you guys see this square? So this is going to be one of those shapes that has 2 ridges. That's why I have that little figure drawn in over to the side. Do we see the shape with the 2 ridges? So basically we have these square cross sections on top of the circle. So on the right and left, we're going to get these little, well, actually on the top and the bottom, we're going to have these ridges go to a point. Okay, so you're going to have your ridges, and they're going to get smaller, and so they go to a point. Yeah. So kind of like a football. Have you seen like a football has like ridges on it? When it's all bound together, it's kind of like that. Not really, but we'll have ridges on them. All right, so if we're going perpendicular to the y-axis, how do you think this problem is different on my setup? We do find the area of a square instead of the semicircle. Huh? Yeah, they're x equals equations. In other words, it's going to be an area in terms of y that we're integrating, and those y values are going to go from negative 3 to 3. So if you see perpendicular to the y-axis, we're integrating with respect to y. But on the last one, if we saw perpendicular to the x-axis, that's integrating with respect to x. Okay, and again, just think about how you're making those chops with your hand. So these are all horizontal lines that we're chopping. All right. So let's figure out our area. Well, it's a square. And the area of a square, square, is
then
the
this
side
This shape is now a square.
squared. Yeah, I just totally named that, didn't I? So we need to figure out the distance for our side. That distance is a horizontal distance. It's from a certain x value to a certain x value, right? It's like when we talked before, like going from -2 to 9. That's a total of 11, right? In order to get that distance, we take the right number minus the left number, right? That's what we're doing. Same idea. So we need to figure out what this right curve and what this left curve is. Because, yeah, I realize that they're both on x squared plus y squared equals 9, but those are going to be two different things when we do what Caitlin said and we solve in terms of x, right? Or like we get x equals equation, solve so that it's in terms of y, I guess I should say. So we're going to take that. So we're going to take our x squared plus y squared equals 9, and we're going to solve for x. Were you asking me a question? No? Okay. You can ask a question. So do you see how we get the plus or minus thing going on? The right side of it is positive x values, right? So this side of the curve are x values that are positive, so it's the square root of 9 minus y squared with a positive all up front. But this side of the curve is all negatives, so that's going to be x equals negative square root of 9 minus y squared. Right? Does that make sense? I had a teacher who always said clear as mud. Clear as mud. I saw him recently and I said, I say that sometimes and I always think of you. All right. It's not clear at all. Mud's not clear, right? Why did he say that? I don't know. So here we go. So we have our volume is -3 to 3. We need to know that distance, that side. What is the distance if I have the right side is the square root of 9 minus y squared and the left side? Yeah, it's the right minus the left. So our side should be the square root of 9 minus y squared minus the negative square root of 9 minus y squared, which makes a total of 2 square root of 9 minus y squared, right? That's what we're going to put in there. Right? Minus the negative.
Yes.
So that could be our a of y equation. As long as we've written that somewhere and we've defined it as a of y, we just write it like that first setup. The volume equals -3 to 3, a of y dy. And we're good. We have the points for the setup. Okay? But if you want to put that in, go for it. This one would not be hard to integrate by hand because we would end up having -3 to 3 of 4 and then 9 minus y squared. See how that ends up going away? Like the square root of the square. So -3 to 3. So I got 144 as the answer. So in the first period class, they were saying, wait, should there be a pi? Put 144 pi. Is it pi? It's not. It's a square. It doesn't have anything to do with a semicircle or a circle or anything like that. Okay, so some of these answers will not have a pi. I know you'll be so tempted to put a pi in because you've been doing that on your homework, but it's not a solid of revolution. It doesn't have a pi. Okay, sketch this one out. So I'll give you a second to try it. All right, so first up, do you guys have it sketched out? So your f of x function is really, like if you write it in terms of y equals mx plus b, it's -1/2 x plus 1. So you should start at a height of 1 and you should go down 1, right 2. Right, so this is going to be the f of x function. Let me draw g of x in a different color. So g of x is going to be 1/2 x minus 1. So it goes up 1, right 2, so it's crossing at that same point. That's g of x. So basically, and we're also trapped by x equals 0, which is here. So we have this little piece in here. Do you guys see the part that's bounded? That's what we call the base of the region. So I'll often refer to the base of the region. So it's like if I had the piece of paper, like those manila folder things I showed you at the beginning, that's the bottom part. That's the part that's graphed. And then off of that, we have different shapes coming off of it, right? So we have shapes that are going to be, in this first case, squares. So we're going perpendicular to the x-axis, and we have a square coming up off of it. So I'm going to call this the side length. How do you think I find the side of the square? Top minus bottom. What's the top curve? We're just going to call it f of x. We're going to make it even easier. Bottom curve? G of x. Easiest way to write that, right? So my area of a square is going to be that side squared, right? It's going to be f of x minus g of x squared. So when I come up with my volume equation, it's going to be from x value to x value. What two x values? No, that's y values. 0 to 2, right? And then we're going to have our side squared. So f of x minus g of x was the side squared. So the easiest way to put this into your calculator, because I know some of you guys have the older calculator like this one on my computer, where it does that like FN int thing when you put in math 9. Yeah, it's really annoying with parentheses, isn't it? It's super annoying. So what I would do is under y1, I would put in the f of x function, which was negative 1/2 x plus 1. And then I'd put in the g of x function for y2, so I'd say, oh, that's going to be 1/2 x minus 1. Because when you go back to your main screen and you do your math 9, what you could do is you could just do y vars function y1 minus vars y vars function y2 squared, and then do your x goes from 0 to 2. Does that make sense? It makes it a lot easier. So we end up getting 2.6 repeating, which if we do math 1, our fave, we get 8/3. So all of this is equal to 8/3. Does that make sense? No? So you put it in for y1 and y2, so it's less things for you to type in eventually. Especially, do you guys see how there's a part A, part B, part C on this question? Why did you get what?
It's weird.
Okay. All right, so B. So the cross sections perpendicular to the x-axis are now semicircles. It's the same original picture, right? But now off of that picture, we have these semicircles coming up off here. So what's the distance that we found before? That top minus bottom is the diameter. So our diameter was f of x minus g of x, right? Yeah?
Since it's a cone, could you just use the cone formula?
Oh, you could. Yeah, this one actually is a cone. Do you guys see how it's half of a cone? So you could find the volume of a cone using your radius at the bottom, which would be 1. And then you could divide by 2 at the end. So yeah, if you notice that you can use geometry formulas, totally do. All right, so our radius ends up being half of that. So we're going to have f of x minus g of x divided by 2. So if I want the volume equation, I say, well, this is a semicircle, so I'm going to have my pi, I'm going to have my radius squared and then that's going to be a whole circle. Do you guys see that pi r squared? So then what? Divide by 2. So I'm going to put it there. Semicircle. So I could do all over too, like the whole fraction divided by 2, but that just seems complicated.
Especially
All right.
if you're just going to pull it off front.
Okay, and we're going to use what we already know. So we knew from 0 to 2 of f of x minus g of x squared was 8/3. So I could actually use that. Do you guys see how? What about the bottom here? So I have divided by 2 squared. What's going to happen when I square the 2? I get a 4.
8/12.
And so then out front I could put a pi over 8, right? Because the pi and the over 2. Did I lose you? Okay, what do I get? So if I square this whole thing, if I square the top, I'm going to have f of x minus g of x quantity squared. What about the 2 squared? 4. 4 times 2?
8.
8. Pi over 8, right? So I have pi over 8 out front. And then I have f of x minus g of x squared. Now you don't feel like you have to do that. If you were like, wait, Mrs. Cox, no. Then you can always just put it into your calculator. But if you see, oh yeah, that kind of looks kind of like what we had before. So if you look up above, that area was 8/3. So I'm going to have pi over 8 times 8/3, which makes pi over 3.
Oh, that is so clean.
Yeah.
Oh, well, if I would have simplified, I would have got
Yeah,
the same
Josh.
answer.
wonder if you're doing like a minus instead of a negative. What's the error say? If it says like syntax error, it's probably like a minus instead of the negative out front. Because are you putting in like negative 1/2 x plus 1? Make sure that this is the short one, not the long one.
And make sure you store it as like an alpha.
Yeah.
I don't even know how to start.
Yeah, did you figure it out, Josh? Okay. So the cross sections perpendicular to the x-axis are equilateral triangles. Are we out of time already? Oh, so sad. I didn't get to this one. Oh, so fun. All right, well, we'll stop there.
Okay.
Are equal